So I am requesting all to mute yourself. Hello.
সাগর বাবুকে বল একটু।
তিনশুক সাগর বাবুকে মিউট করে দাও। তিনশুক সাগর বাবুকে মিউট করে দাও। Good afternoon. Today is our second day of our 3 days national workshop on climate smart livestock production in India. Today we have 3 sessions. First session is the third session of this workshop. The topic of the discussion is greenhouse gas emission from livestock and their mitigations. The talk will be delivered by Professor D.N. Kamra. He is the man of animal nutrition. Followed by the second session, the fourth session of the workshop. It will be on the new approaches to climate resilient livestock production. Speaker is Professor L.K. Babu. He is a man of livestock production management. And the third session of today, that is the fifth session of the workshop, will be on impact of climate on livestock and poultry production in Sundarban. It will be delivered by Dr. B. Banerjee. He is a man of veterinary physiology. So today, there is a multidisciplinary angle for the discussion about the major issue, the climate smart livestock production of India. And from the different angle, our eminent speakers will discuss, and probably we can get a fine definition, a clear-cut destination about the mitigation issues, how do we can progress about the climate stress condition. Now, before starting today's program, there are some important announcements. Yesterday, practically, there are some problems about in our chat box and some feedback problems. We got so many emails and so many messages from the participants. So considering the situation, we decided the chat box will be opened from the first session. But we have a request to all the participants, don't put your name or personal details. It is only used for the questions to the speakers. And I am requesting to all the participants. Namaskar, sir. I am requesting to all the participants, please write the pertinent questions on the discussion, the particular topic of the discussion. And the feedback will be provided within the chat box. During the third session, you will get sufficient time to give your feedback before the closing of the session. Otherwise, you may copy the link of the feedback and you can send it later within 10 p.m. of tonight. And today's feedback and tomorrow feedback is very essential for getting the e-certificate. So I think there will be no problem from today. Your cooperation is highly solicited. Now we will start our first session. This is the third session of the workshop. Our speaker is Professor D.N. Kamra. Professor D.N. Kamra has been working in the field of animal nutrition, research, training, and administration before his retirement as ICR National Professor in 2002. He specializes in human microbiology, biotechnology, microbiome of rumen, methane inhibition, and stimulation of fiber degradation, and to enhance nutrient availability of ruminant feed. He has worked in multiple geographies, including India, North America, Australia, UK, Germany, Austria, and Switzerland. He has submitted 3 patents for Jepsol 101 and organic source of selenium for the feeding of animals in 2009, anti-methane and herbal combination for inhibition of Methanogenesis in ruminants in 2010, and methane suppression, an essential oil for the feeding of animals to inhibit the Methanogenesis in 2012. He has got over 300 publications. 5 top papers have been quoted by 1,155 researchers in their publications. He has been responsible for establishing a state-of-the-art rumen microbiology laboratory, which may be identified as one of the best laboratories in India, and has all facilities required for cultivation of anaerobic rumen microbes. He has been awarded 13 times by different organisms like Rafi Ahmed Kidwai Award and Bharat Ratna Dr. C. Subramaniam Award for Outstanding Teacher for the Best Teaching in Animal Nutrition from the ICAR New Delhi. Professor Kamra got NAS Fellowship, Dr. P. Bhattacharya Award of NAS, and Recognition Award of NAS by the National Academy of Agricultural Science, New Delhi. 3 authorities in India like CLFMA, Animal Nutrition Association, and Indian Society for Buffalo Development have confirmed lifetime achievement award for its contribution to animal science. Has been awarded twice for his nice teaching caliber, once by IVRI, then by ICAR. 2 of its students were awarded Jawaharlal Nehru Award for their outstanding research leading to PhD degree, and one of these students received N.D. Kehar Award for his PhD thesis from Animal Nutrition Association. He published 9 books and edited 6 books, which are accepted by students and teachers of animal nutrition and allied subjects. With this, now I am requesting Professor Kamra sir for deliberation of his speech on greenhouse gas emission from livestock and their mitigation. Professor Kamra sir, please start your lecture, and I am requesting Dr. Kinshuk Das, Assistant Professor of the Department of Veterinary Physiology, and Dr. Ramlan Patro, Assistant Professor of Animal Nutrition, to act as the rapporteur of these sessions.
And other dignitaries present in the really very thankful to all of you that were giving me a chance.
Problem with some sound.
Sir, some sound problem is coming, Kamra sir. Sound is not coming clearly.
There's problem with sound.
Yes, sir. Sir, you use the headphone. Please use the headphone.
There's an echo which comes around.
That's okay.
Sir, unmute yourself, sir.
If
Kamra sir, please unmute, sir.
if he doesn't have a mic, he can come closer to the computer.
Sir, yes, sir. Now
it's okay. Hello.
Yes, sir. Yes, sir. Now it is coming.
Hello, Dr. Das.
Yes, sir. Sir, now it is coming, sir. You can talk.
तो फिर लगाओ उसके अंदर.
Kamra sir, now it is okay, sir. Sir, unmute. Yes, sir. Now, sir. Now, sir, please start, sir.
Yeah.
Yes.
Why is that? You are able to hear me.
Yes, sir. Yes, sir. Yes, sir.
You are able to listen to
Yes, sir. We are able.
sound and video both are okay.
No, sir.
Okay.
Video yet not started.
So, respected Dr. Madan. Yeah? Pardon?
Yes, sir.
Yeah, it's better now, but you will have to speak closer to the computer. Be a little closer to the computer.
Okay.
Yes, this
Okay.
is yeah. Now
So,
it's better.
it's okay.
Yes,
Thank
sir.
you. Thank you.
You all. Respected Dr. Madan and Dr. Das, it's my great privilege that I'm given this chance to speak today to this august gathering of scientists from different disciplines. So I have a recorded presentation which I'll be presenting from now onwards.
The topic assigned to me is greenhouse gas emissions from livestock and their emissions. Distinguished chairman, respected speakers, organizers and participants of this webinar on climate smart livestock production in India. We thank the organizers of this webinar, especially Professor
Now the audio and video
and Dr. Amlan Azra,
is clear.
who have given us the chance to meet the stalwarts of animal physiology and animal nutrition. I've divided this lecture into 4 different sections. The first is the greenhouse gas emission and mitigation techniques. The second one is phytochemicals, that is plant secondary metabolites. The third section.
Yeah. So now it is clear, the audio and visual. The audio and visual is clear, Dr. Das?
Yes, sir, it is clear. You continue.
Yes, sir. Yes, sir. It is clear. It is clear.
It is clear.
It is clear, sir.
Methanogenesis.
So,
And the last
sir,
is
during the time of playing this video, you just mute your own.
cooking of the fires and global warming, driven microbial ecosystem, and other related topics on internet, open YouTube, and such.
Sir, please unmute yourself. Sir, please unmute yourself. You are not audible.
Sir, audio is not coming.
Sir, please unmute, sir. Kamra, sir. Please unmute yourself.
Kamra, sir, you unmute, sir. But the sound problem is coming, sir. Sound problem is coming, sir.
Now,
Yes, start, sir.
just full screen this one. Full screen this one. Don't go back to Google Meet. You just full screen this one.
Sound in video is not coming. It is muted.
Sir, please
And
start.
it's not getting to the full screen also.
Let's start from first first. First part yet not clear, sir. Sir, start from fast.
But Shama, Dr. Kamra, their voice sound is not coming. It appears you have muted your presentation.
Global man-made green.
Yes, sir. Sir, it came, sir.
Okay.
Sir, just a moment it came. Sir, it will be better to start from fast. Yes, sir. Yes, sir. You start it, sir, from there. From fast, sir. Yes.
On the earth, because the greenhouse gases are present. The greenhouse gases, when more than the normal levels are present in the climate, are responsible for global warming. Greenhouse gases are produced anthropologically due to agricultural activities, by industrial activities, which live a very long time in the climate and have a very high global warming potential. Therefore, they are much more dangerous than the agriculturally produced gases. Carbon dioxide is considered to have a unit of 1 global warming potential, and in other gases, global warming potential is comparatively calculated. Anthropologically produced gases are carbon dioxide, methane, nitrous oxide, water vapor, etc. Industrially used gases are hydrofluorocarbons, perfluorocarbons, and sulfur hexafluoride. Their use in industry has been stopped and therefore are not so dangerous for the climate. After industrial revolution, about 250 years ago, there has been an increase and decrease in water vapors depending upon the climate temperature. The concentration of carbon dioxide increased by 34%, methane by 152%, and nitrous oxide by 18%. A decrease in industrial gases has been observed as the use of these gases has now been stopped. Water vapors cause about 36 to 70% of the greenhouse effect. That is the highest effect on global warming. Carbon dioxide causes 9 to 26%, methane 4 to 9%, and ozone 3 to 7% of the total greenhouse gases. The global man-made greenhouse gas emissions are electricity and heat 31%, agriculture 11%, transportation 15%, forestry 6%, manufacturing 12%. The greenhouse gas emission is maximum by China, 24.2% of the total, followed by US, European Union, and India, 6%, Russian Federation, Japan, Brazil, and Indonesia, 1.9%. That is at the 8th level of carbon dioxide or greenhouse gas emission by the countries. Highest carbon dioxide is emitted by China, about 9,057 metric megaton, followed by US, India, 2,077 metric megatons, Russian Federation, Japan, Germany, Canada, Saudi Arabia, Australia, UK, and Italy, 326 megatons. That is at the 18th number as far as the different countries are concerned. This carbon dioxide production per kg of different foods indicate that the production is higher in non-vegetarian foods, beef, lamb, and pork, as compared to vegetarian foods, rice, milk, cereals, except rice, fruit, and vegetables. Therefore, taking minimum quantity of non-vegetarian food might control the global greenhouse emission and in turn the global warming. The carbon footprints of the travel by aeroplanes and by road transport, it is given in carbon dioxide equivalent per passenger kilometer. The flights, domestic, short distance, less than 463 kilometers, produce 257 gram carbon dioxide per kilometer, and international long distance flights produce 113 gram carbon dioxide per kilometer. As far as the land transport is concerned, in Europe in 2011, it was reported by the European Environment Agency as 109 gram carbon dioxide per kilometer. Vehicle average figure for CO2 emissions per kilometer of road travel for 2013 in Europe. The International Council on Clean Transportation, the newly registered passenger cars, they produce 127 gram carbon dioxide per kilometer. Hybrid electric vehicles, 92 gram CO2 per kilometer. And light commercial vehicles, 175 gram carbon dioxide per kilometer. The livestock population and methane production in different parts of the world, the North and South America, collectively have 20% of the world livestock population, but they produce about 32% of the methane emitted by animals. Africa has 19.3% of the population, but produces methane equal to 14.8% of the total. Similarly, India, with 13.4% of the livestock population, produces only 12.3% of methane. According to the United Nations Framework Convention on Climate Change, the energy sector of India is largest contributor of the greenhouse gases. The sector emitted approximately 2/3 of the total emissions and is followed by the agriculture and industrial processes in 2018. About 44% of the livestock emissions are in the form of methane. The remaining part is almost equally shared between nitrous oxide, 29%, and carbon dioxide, 27%. As far as the international agreements are concerned for control of the greenhouse gases, in 1992, the UN Conference on Environment and Development was held in Rio de Janeiro. The parties to the UN Framework Convention on Climate Change met in Berlin to outline specific target on emissions. In 1977, in December, the parties concluded the Kyoto Protocol in Kyoto, Japan, in which they agreed to broad outline of the emission targets. 2004, Russia and Canada ratified Kyoto Protocol to the UNFCCC, bringing the treaty into effect on 16th February 2005. In 2011, Canada was the first signatory to announce its withdrawal from the Kyoto Protocol. In 2012, on December 31st, 2012, the first commitment period under the protocol expired. 197 countries ratified, including all the members of United Nations and European Union in December 2015. The objective was to stabilize greenhouse gas concentrations in the atmosphere at a level that would be with the normal climate. Considering signed protocol at Kyoto, European Union, Bulgaria, Czech Republic, Estonia, Lithuania, Monaco, Romania, Slovakia, Slovenia, Switzerland, US, Canada, Hungary, Japan, Poland, Croatia, New Zealand, and Russian Federation, Ukraine, Norway, and Australia, Iceland signed this treaty. In 2015, all 196 parties to the convention came together for the UN Climate Change Conference in Paris in 2012 and adopted by the consensus. So therefore, the different countries have committed to limit greenhouse gas emission as per their convenience, and maybe in the near future, they will be able to control majority of the greenhouse gas production from different activities of human beings and industry. And naturally, the industrial inhibition of greenhouse gases will be very large, and it will decrease the total level of greenhouse gas in the atmosphere, and in turn, which will be reducing the global warming potential, and the climate of the Earth might be better. But that will all depend upon the sincerity of the different countries which do their business of controlling the greenhouse gas production as per the need of the hour. Thanks. Phytochemicals are plant secondary metabolites. Most of the plant secondary metabolites are antimicrobial compounds, but all of them are not effective against all the microbes. Therefore, primary in vitro screening is a must to select proper plant secondary metabolite or inhibition of a particular microbe. The phytochemicals present in the plants, they are mostly saponins, tannins, lignins, phenolic monomers, essential oils, triterpenoids or steroids. And the major function of these plant secondary metabolites are a defense mechanism of the plant for protection against the invasion by the pathogens or foreign particles. From phytochemicals, what do we expect? There are three major functions we wish that plant secondary metabolite which we select should have. The first is the inhibition of methanogenesis in the rumen, inhibition of protozoal growth in the rumen. They should either be able to stimulate fiber degradation or at least not to inhibit it. The strategies to mitigate methanogenesis is the replacing low-producing livestock with high producers. Mostly in the tropical countries and the poor countries, the majority of the animals, they are low producers. And that is why the methane generation is very high. So therefore, we should replace the low-producing livestock with high-producing animals. Second is to enhance degradability of poor quality roughages, because majority of the animals in tropical countries, they are being fed on roughage-based diet, which have poor digestibility. If they are able to treat them before feeding to the animals, and the digestibility of these feeds can be enhanced. Third is the inhibition of ciliate protozoa. Fourth, the use of alternate hydrogen sinks, reductive acidogenesis, and reduction of unsaturated fatty acids. The feed additives which you can use for inhibition of methanogenesis by the ruminants, they include chemical feed additives, microbial feed additives, and the phytochemicals are the plant secondary metabolites. And the last of all is the biotechnology techniques. Of course, we are not in a position at present to give a technology for feeding to the animals for reducing methanogenesis by using biotechnology techniques. But the selection of microbes which are inhibitory for methanogenesis can be selected and fed to the animals. In vitro methane inhibition, the in vitro screening of feed additives is a must before testing them in vivo experiments. In vitro screening can be done in 100 ml graduated syringes or serum bottle of 100 ml capacity under anaerobic conditions. The feed additives can be tested for methane inhibition, stimulation or inhibition of digestibility, and in vitro volatile fatty acid production during fermentation. The effect of plant extracts on inhibition of in vitro methanogenesis. It is wonderful that water extract of only Allium cepa, that's onion, inhibits methanogenesis, and there is a production of 33% lower methane production in comparison to control. Allium stivum, Rhizobiacta indica, Cannabis indica, Pheniculum vulgare, the alcoholic extracts of all these plants inhibit in vitro methanogenesis. Only the methanol extract of Amblyca officinalis, Eugenia jambolana inhibit methanogenesis. Ethanol and water extract of Sapindus mucorosi are highly inhibitory for methane emission by the rumen microbes. The plants have been screened for inhibition of methanogenesis, and the figures show that the plants which have been shown in green color, they are able to inhibit 25 to 50% of methane in vitro cultivation of microbes. And the red color figures are for those plants which inhibit methanogenesis more than 50% of control. The plants which inhibit ciliate protozoa, the protozoa inhibition is between 20 to 50%, which is shown in green color, and more than 50% inhibition in red color. And majority of the methane inhibitors are also found to be good protozoa inhibitors. In vivo methane emission. It is not essential that plants contain metabolites containing feed additives which show anti-methanogenic effect in vitro might also show the similar effects in vivo. We have screened more than 100 plants, plant extracts, essential oils, but all these plants which show in vitro effects on methanogenesis might not show similar effects in vivo experiments. Therefore, these plants cannot be used as feed additive to the ruminants, which show good results in inhibition of in vitro conditions, but not show the similar effects in vivo conditions. Methane mitigation techniques. There are several techniques in which the methane can be mitigated. The replacement of unproductive by high productive animals. Reducing the number of low producing animals. Inorganic terminal electron acceptors like nitrate and sulfate, etc. Organic feed additives based on plant secondary metabolites. Methane analogs, which are required in extremely low concentrations of chloroform, carbon tetrachloride, and methylene chloride. Unsaturated fatty acids, then rumen manipulation by defaunation of the animals, and if the people start eating lesser red meat, it will lead to a reduction in total methane production by the animals. The effect of defaunation on the methane production in buffaloes in defaunated animals where the protozoa have been eliminated, the methane emission is lower than that in defaunated animals. This might be because of lower hydrogen production in rumen in the absence of ciliate protozoa. On defaunation, the dry matter, total digestible nutrients, and digestible crude protein intakes were significantly lower as compared to faunated animals, indicating superior feed conversion ratio in the absence of protozoa. But there was no change in the body weight gain in the animals. The effect of defaunation on the biochemical characteristics of the rumen liquor are concerned. The rumen pH was lower in defaunated animals. Total volatile fatty acids, total nitrogen, TCA soluble nitrogen, amino acid nitrogen were higher in defaunated animals. There was a decline in pH, ammonia nitrogen, and methanogenesis, and an increase in propionate concentration in the rumen liquor. All these parameters indicate that there is an improvement in feed conversion efficiency in defaunated animals. There are a few experiments which we have conducted in our laboratory are explained here, in which a combination of these feed additives containing plant secondary metabolites have been used, and their effect on in vivo methane production and growth performance of the animals has been studied. The composition of the RM3, it contains 3 different plants: Umbilica officinalis, that is amla, Trachyspormum emi, ajwain, and Pheniculum vulgare, that is fennel. They are mixed in equal proportion and fed to the animals. In this experiment, there were 4 different treatments: control, sulfur at the rate of 0.05% of diameter intake, and rumen RM3 along with 1.5% diameter intake, and RM3 as well as sulfur in the same ratio is fed to the animals. There is a decrease in methane production, about 15% of that in the control on feeding RM3 at the rate of 0.75% of the feed intake, and average gain in body weight was increased by 12.2% in comparison to animals not given any feed additive. There is a second compound which has been used, that is antimethane. It is a patent submitted by our group and still not granted. So therefore, their composition has not been given here. And the animals were fed wheat star and concentrate in 50-50 ratio for the maintenance as per NRC 2001. The treatments were the control without any feed additive. Group 1, antimethane at the rate of 1% daily. Group 2, antimethane at the rate of 2% of diameter intake once in 2 days. And Group 3, the antimethane at the rate of 3% of diameter intake once in 3 days. It means that we have all the groups of animals, they were fed same quantity of feed additive, but one is given every day, other is given alternate day, and the third group, which is given on third day. In Group 1, when the feed additive, that antimethane, was fed at the rate of 1% of feed intake every day, methane emission was 6.8 to 6.9% lower than the control. Methane energy loss was also significantly lower in Group 1 as compared to control. On feeding antimethane and the performance of the cows, it has been conducted for 152 days. Concentrate and wheat star ratio 1:1, and there was only 2 groups for this experiment of growth. And average daily gain was 11.1% higher in antimethane fed animals than the control animals, with 8.8% higher feed intake. The benefit of feeding antimethane is that there was a decrease in 32% of methane emission in the feed additive fed animals as compared to control. And there was a better feed conversion efficiency, no adverse effect on the feed utilization and rumen fermentation parameters in buffaloes. The cost of antimethane is only rupees 1.98 per head per day of the buffalo calf, which is affordable by the farmers in terms of the benefits he gets. In another experiment in which the RM7, there were the 7 plants in the metabolites, they were mixed together, the Maduca latifera, that is Bava seed cake, Paniculum vulgare, fennel seed, Adadilacta indica, neem seed cake, Terminalia bellarica, Baheda, Amblyca officinalis, that is called Amla, Trachispermum emi, that is Joine, and Terminalia jabula, that is Harald pulp, in the ratio of 2:1:1:1:1 ratio respectively. The first 3 compounds, they were used at 2 parts, and the last 4 plants were used as 1 part of the feed additive. In growing buffalo calves at 4% of RM7, there was a significant decrease in methane emission in terms of liter per day, liter per kg diameter intake, and liter per kg digested diameter intake. And the average body weight gain was 14 to 14.5% increase in buffalo calves at 2 to 4% of RM7 as a feed additive. So therefore, in this experiment, it shows that 2% of the RM7 given to the animals causes 14% increase in body weight as well as methane emission. There was an essential oil, wine oil, and nitrate was fed to the animals. 16 to 18% inhibition in methane production. F. Succinofibrovector succinogenes, Rhinococcus flavifaciens, Rhinococcus albus, Methanogens, and fungi did not vary with the treatment. There was no correlation of methanogenesis with the number of methanogens present in the Rhemonlica. The feed additive 7, it was a blend of essential oils, blend of essential oil 2. In 180 days, there was no difference in feed conversion efficiency among 3 groups. Methane production liter per kg diameter intake and liter per kg digested dry matter intake was significantly reduced by 14 and 14.6% at 0.15 ml per kg of dry matter intake, and by 14.2 and 13.8% in 0.3 ml per kg dry matter intake, respectively, along with an improvement in body weight gain. The summary of the different compounds which has been used and found positive for methane inhibition. That is, the first is blend of essential oils, 14.6%, Terminalia jabula, 24.6%, Ficus bengalensis leaves, 21.8%, Alto carpus heterophyllus leaves, 20.6%, Azathirophylla indica leaves, 24.07%, lower methane production in experimental animals as compared to that in the control animals. Methanogenic rumen microbes and methane inhibition. Methanogenic archaea are responsible for methane generation in the rumen. Usually one particular microbe, when increases or decreases in the ecosystem, their products always increase or decrease accordingly. But in the case of methanogens, they do not have any correlation with the methane generated in the rumen. Methane production in the rumen is an essential event. During fermentation of feed, particularly the roughage-based diet in the rumen, a lot of molecular hydrogen is produced, which has a high octane value and is highly combustible, which might be very dangerous. In addition to hydrogen, carbon dioxide, volatile fatty acids, and a small quantity of other products are also produced. Methanogens convert carbon dioxide and hydrogen to a less dangerous gas, that is methane. Hydrogen utilizers convert these gases into short-chain fatty acids, which can be used as an energy source by the animals. Methanogenesis causes harmful effect in two ways: increasing the global warming and decreasing the feed efficiency. Then there are culturable rumen methanogens. Only 5 genera and 8 species of rumen methanogens have been cultivated in vitro in the present techniques available in science. These are Methanobacterium, Methanobrevibacter, Methanomicrobium, Methanopleus, Methanosarcina, etc. When we use the metagenomic techniques, methanogens and hydrogen utilizer in the buffalo, it has been reported that there are 18 methane generating bacteria and 5 hydrogen utilizing bacteria, which can use hydrogen and carbon dioxide and convert it into volatile fatty acids, which can be used as a source of energy. The methane production on different feeds, the straws are the highest methane producers and the concentrates the lowest producers. Other feeds lie in between these two extremes. The selection of feed ingredients is very important for lower methane generation by the livestock. If we compare two different animal species, that is yak and cattle, we find that when they are fed the similar diets, there is more methane generation in cattle than that in yak. But the number of methanogens was equal in both the species. Hydrogen producers were higher in cattle. Therefore, it appears that high hydrogen production and high hydrogen producing microbial numbers were better correlated with methane generation, while the methanogen numbers were not correlated with methane generation. With the plant secondary metabolites, the methanogen depression was between 36 to 96% in vitro conditions, and in vivo experiments, methane inhibition was from 10 to 29% with the same inhibitors. The rumen manipulation showed a significant inhibition in methane emission, while there was only a slight improvement in digestibility. There was 24% inhibition in methane production on high roughage diet, and there was 20.4% inhibition in methanogenesis on low roughage diets. There was no effect of diet on total methanogens estimated by real-time PCR technique. No effect of diet on methanogens. There was high abundance, 47 versus 43% of the methanobrevibacter in 70% TDN diet. Methanospirillum and methanococci high in 100% diet, TDN diet. Archaea diversity was more with high fiber diet, that is 70% of the TDN requirement. There was no difference in other methanogens in all the diets. There appears to be no correlation of methanogens with methane emission. The constraints which we have observed for in vivo methane inhibition are lack of precise methane emission techniques, limited in vivo studies, complex human microbial ecosystem, no correlation between methanogens and methanogenesis, positive correlation between hydrogen producers and methanogenesis. Other studies might also show different correlations than the reported so far. The strategies for the reduction of methane emission by the animals is lignocellulosic feeds produce more methane as compared to cereal grain or concentrates. If you replace troughs with the grain in the ration, methane emission per kg feed intake is reduced considerably, but it has a competition with human beings for food and feed. The other strategies include feed additives containing plant secondary metabolites and terminal electron acceptors, which can be used for inhibition of methanogenesis in the ruminants. The future work includes that the microbiome and the enzyme profile of the human needs to be identified for feed degradation and inhibit methanogenesis to make the livestock production economic and environmentally friendly. There are many feed supplements and feed combinations which can inhibit methanogenesis. There are only a few plants like Terminalia jabula and Allium stylo, which stimulate fiber degradation too, in addition to the methane inhibition they have in the rumen. The phytochemicals can be used to inhibit methanogenesis, but in vivo experiments are required on large number of animals for longer duration before final recommendation. Defaunation has a proven effect on inhibiting methane emission. Method of defaunation and to keep the defaunated animals needs to be studied.
Thank you, sir.
Thank you very much for listening.
Thank you, sir. Thank you, sir, for your nice presentation and resourceful presentation. And the issue of methanogenesis, which you have explained, and the experimentation in different model of pharmaceuticals, feed additives, methane analogs is very important for us. And it also not only increase the methane production, it also reduce the feed efficiency. As you have addressed is very nice. So I think our participants will be enriched about your presentation. Now I am requesting our rapporteur, Dr. Das and Dr. Pakro, to place some questions for the discussions. Sir, you stop presenting, sir. Kamra, sir, you please put the stop presenting. Yes. Dr. Pakro and Dr. Das, please.
Thank you, sir, for your presentation on the mitigation of greenhouse gas production from ruminants. Sir, actually, we have received many questions. So I will start on first. During COVID-19 lockdown, greenhouse gas and greenhouse gas worldwide, despite agricultural production continued at the same level. But animal agriculture is blamed for one of the substantial driver of climate change. Actually, animal provides sustenance to our hive or reality. Sir, could you follow? And animal agriculture is blamed for one of the driver of climate change, but it provides us sustenance also. So is blame a hype or a reality? Sir, could you follow?
Please explain your question.
Could you hear? Greenhouse gas concentration during the lockdown situation, but animal agriculture is blamed for it. So is it a reality or is this blame is correct or just it's just a blame for the animal agriculture production?
I think the
Okay, I think you're not here already. Okay, I will go for the next question. Sir, could you hear?
Dr. Patro, you please the second.
Could you hear, sir? Okay. Is there any possibility to explore the individual and genetic variation of Methanogenic microbe to mitigate methane production in ruminant? Is there any possibility to explore the individual and genetic variation of Methanogenic microbiome to mitigate methane production in ruminant?
There are many cuts in your question. I will get
Because
actually much know. The audio is not good for you.
excuse me, it's not audible properly.
There are many cuts in the question. If you can follow
There's a sound problem around.
Yes, sir.
We can't hear what is being said.
I have some problem.
Kamra sir, your sound is not clear.
I have sound problem or
well, the same thing is with me also. I think we got some yeah, I can't hear the question.
Kamra sir, Kamra sir, your sound is not clear, sir.
Yes. There are between the cuts between the sentence. There are few words that are missing. We are not listening. One can understand what actually was.
I cannot hear you also properly.
But
I
the top one,
cannot hear.
the top one's okay.
I think there is problem. Am I audible to all?
Yes, Dr.
No, it is better.
No. Dr. Patro, it is not
Sir,
proper.
am I audible?
Kamra sir,
Yes,
Yeah, you are audible.
yes,
you
yes,
are
you are audible, but the question sound from Kamra sir is not coming clearly. Kamra sir, Kamra sir, please check the sound, sir. Sound is not coming to us. Your sound is not coming to us. Now, sir, again, sir, you unmute, sir, then you can.
Now you are listening me?
Yes, sir, now it is clear.
Yeah, now it's
Dr. Batra.
Dr. Patro, you place the last question.
So I will ask question, same question.
Last question,
Okay.
last question.
Is there any possibility? Yes. Is there any possibility to explore the individual methanogenic microbiome to mitigate methane production?
Yeah, of course, because there are very few methanogens which are responsible for major portion of methane synthesis. If we are able to eliminate 2 or 3 bacterium, the archaea, it will be possible to inhibit methanogenesis. But not much work has been done on this particular aspect.
Okay, thank you, sir. So, just
I had
another one question I will ask. How we
I had one thought which I could share
Yeah.
Okay, sir, you can ask.
with Professor Kamra. Dr. Kamra, you said about this meat eating, about which is a little concern to me. We should eat less meat.
No,
Less means how much less? When we talk of an Indian situation, we are already so low.
Yeah.
And meat, in fact, in India, if we take the total Methanogenesis, the contributions from those which were involved in the production of meat as such, because meat is a byproduct in India, not a main product.
No,
We produce milk. So eating is not going to alter it. Or if we propose like that, we might be sending a wrong signal.
Not all the meats I am talking about. I talked about only red meat. Because in red meat, it is 35 kg of carbon dioxide produced per kg production of the meat. While in chicken, it is only 4 kg. So therefore, the production of greenhouse gases in red meat production is much higher. If we are able to reduce it to half, naturally it will be significantly.
You see, in India, red meat is all coming mostly from buffaloes, which we consume in the country. Yes. And buffaloes are primarily not for meat; they are for milk.
Yeah.
Whatever meat we come out of it is a byproduct. Yeah. After they have spent, now they go to the slaughterhouse for that, or the male calves, which are of no use, go to the slaughterhouse. Now, if we talk in Indian conditions, then we say that we should reduce meat consumption. I'm just wondering, we are not sending a wrong signal, as if we are really using animals for meat purposes. This is what my concern is. This is my concern.
It is only in India. There are many countries in the world which are producing the animals, ruminants, only for meat production. So naturally, they are producing much higher greenhouse gases than what they could have done.
For once, which animals?
Pardon?
Which animals are those which are used for meat production alone in India?
In cattle. Not in India. Throughout the world.
Yeah, I'm not talking of the world. I'm saying that once we say that in India, we are already in problems on that score. So we should not give more signal to that yes, we should reduce meat consumption in India. That's what my concern.
No, not meat, like sheep. Sheep is being taken and goat is being used as the meat animal.
Yeah, but that's not red meat.
Yeah?
Sheep. Yeah. See, that's not red meat, as a matter of fact.
No, not red meat, but naturally the production of greenhouse
and
gas.
Our sheep and goat are not produced through concentrates. Our sheep and goat are produced through straws and blades of grass, which they pick up.
No, that is why they are producing more methane.
Yeah, but
if they are given grain,
but that's what the estimate is not there. That estimate for that is not there. That how much is where
I agree with you that if they are eating only on the straws, naturally they will be producing more methane. And if they are being fed on the grain-based diet, so methane production will be much lower.
Sheep and goat is an animal which is important for the livelihood of our people.
Yeah.
In the grab of saying that it's producing more, are we not taking out the livelihood from our people? As a matter of fact, that we should have more of goats, more of sheep, and more livelihood propositions for those people who are landless. And for them, therefore, this is an occupation. I'm just saying that maybe that we'll like to be a little guarded in saying these things, because there are people who will pick up in the country at present. Any small word here or there is being picked up, and will say that Devaki Nandan says that you see that there is meat. less of it. So kindly don't take it. So
No,
there will be tomorrow big
this
headlines. on it.
presentation,
That's what-
because
that's
it
what
was
I'm
in a
saying.
webinar, it is because it was a webinar, I thought that people
My concern is
throughout
only
the
that.
world might come in.
Yeah.
Yeah, that is why I included all these things. But
Thank you,
in
sir.
the
Thank
case
you,
of
sir.
sheep and goat, it is our.
Okay, sir. Thank you, sir. Madan sir, you have explained it in other ways nicely. So now, Dr. Fiksut Das, do you have
Thank
any
you,
more
thank you.
questions?
Thank you.
Dr.
Yes, sir.
Yes.
Thank you, Professor Kamra, sir, for your nice deliberation. Actually, nearly 200 plus participants are actively present in the live YouTube streaming session. So we got a lot of interesting questions. And I just picked up on one question, and many of them asked in similar direction. That, sir, actually, it is very difficult to make the farmer understand what is methane emission, what it is impact, and bad thing like that. So for them, could you suggest any readily available economical feed additive or feed? Can you suggest for them? We can suggest for the farmers.
Yes, there have been many studies in which the low methane producing feeds have been identified. And those feed, if they are available with the farmer, they can feed the animals. But if they are not available with the farmer, he will not go to market and purchase those feeds. So I totally agree with you that because this, it depends upon the methane, means on the feed which we give to the animal. So naturally the methane production will depend. That is true. But the problem is that the people, the farmers, especially in India, they don't have purchasing power. Whatever is available with them, they will feed to animal. He is not bothered कितना green house gas बन रहा है, कितना global warming हो रहा है, उससे इससे कोई मतलब नहीं है. If he is feeding 4 rupees of worth of feed today, tomorrow he should get 6 rupees worth of benefit. Then only he will feed the animal. We can't teach him that he should take this feed and he will be producing lower methane. So naturally, if it produces lower methane, where does it matter to him that what is methane? So we have to give a local language pamphlets that if preferably they have got these feeds, he can feed to the animals.
Sir, another question we got, that is that you have suggested that replacement of low producing animal with high producing animal. But these low producing indigenous animals are more adaptive. So it seems a little bit controversial, and what would be the best suggestion?
Yesterday we had a same discussion with Dr. Madan, which he wanted that we will talk sometime separately. In isolation, I don't know. But the problem is that if this is the only way for any country to reduce greenhouse gas emission, if they are able to reduce non-producing animals or low-producing animals, so naturally the methane production will be 30 to 40% lower, and our problem is solved. But then he will say that we are in India and we should not talk about that. Because it's a policy matter, the government of India may or may not.
Okay, okay,
Dr. Madan?
I think that primarily, I think that we should say a spade. Very often that we are afraid in saying a thing which we feel that may not have the right type of responses. Many a times that I'm a victim of that, but it doesn't matter. If you are saying the right thing, you say it right thing. What is it? That in the ministry,
What I'm doing is that I'm going on your footsteps.
Yeah.
If people don't like it,
in the ministry also, I pointed out this thing. We are spending about. I pointed out that about 280 crores are being spent on a particular type of a technology. Now that technology is being put into a gear. I pointed out that where these things have to be tackled in, that it's no fun giving money, constructing buildings, constructing facilities, and then there is no person in there to take care of it.
Yeah.
So why not to go it in a reverse way? Have the man functional, give him all the facilities to be functional, and then add to him in terms of his buildings and laboratories and other things, so that he feels empowered, rather than we get somebody to enter a building about which he does not know. So these are the things which we need to say it, but I'm sure that sometimes some people listen, sometimes they may not listen. So we should be happy. If somebody listens, we should be happy. If somebody doesn't listen, we should still be happy that at least we have created a thought in him.
Usually, I give an example
Thank you, sir.
in my presentation.
Thank you.
The farmer, which is not beneficial to him. So naturally, he will kick me out of his village. And this is one of the ways to put him on our way. He should think like we are thinking. And that he will do only when he has got purchasing power. If he doesn't have purchasing power, so naturally he can't do anything, he can't help him.
Probably 10 million more animals are living today on the surface of India. In terms of carrying capacity, and they were living 2 years back. So those 10 million people are producing gases and methane and all that. And we must not ascribe that production. They are unproductive and producing gases, and put it onto the shoulder of those animals which are active and producing and giving benefits to the farmers. That's it. Okay. Thank you. Thank you, Dr. Kamra.
Sir, Dr. Kamra, sir, actually, in the Google Meet platform, Dr. Sejian has asked one very interesting question. Dr. Sejian, sir, asked that, is there any possibility to explore any vaccine against that methane emission or methanogenesis?
They have conducted one project of vaccine production, but I don't think the Australian have already failed in this aspect. When they took
Dr. Sejian, yes, sir. Dr. Sejian,
when they took this project, I was really surprised that why they are going to work on vaccine. Because there are many microbes, many archaea in the human, which are responsible for methane production. If the best organism producing methane that is inhibited, the lower methane producer, they will increase their capability and again produce quantity of methane. And the exact result and the which they have found at NIANP, the doctors here, they can be able to tell much better than what I can do.
Okay, sir. Thank you. I think Dr. Das, you have already finished the questions. Mr. Das, is there any more questions?
Thank you, sir.
Okay.
No, if you have any question, you can send me a mail.
Okay, sir. Yes, sir. The time is already, we have crossed the limit of the timing. Yeah. Many thanks, sir, Kamra sir, for your nice presentation and discussions. And again, we are from the parts of organizing committee. Thanks to you for your presence and resourceful presentations and discussions. So thank you, sir. Thank you, sir. Now we will, yes, sir. Now we will start our second session. That is the fourth session of the workshop. Our speaker is Dr. L.K. Babu, Dean, College of Veterinary Science and Animal Husbandry of Odisha University of Agriculture and Technology, Bhubaneswar. Dr. L.K. Babu completed his BSc and age in 1989 from OUAT, Bhubaneswar, as first-class first gold medalist and best graduate. He completed his MSc in animal production in 1991 as first-class gold medalist from OUAT and PhD in 2000 with gold medal as best student of the institution from IVRI with ICR Senior Fellowship. He was conferred with the Fellow of Indian Society of Animal Production and Management in 2020. He has received several awards such as G.D. Narayan Khetkar Memorial Award in 2016 for significant contribution in animal husbandry and OUAT Best Teacher Award in 2009. He is also acting as the Vice President of Central Executive Committee of Indian Society of Animal Products and Management, SPARC. He has guided 24 PhD and MDSc students as guide and co-guide and published more than 55 research papers in national and international journals. He is having the administrative experience in different capacities as Dean Students Welfare, Dean Postgraduate Faculty cum Director Residency Instruction in Charge, and Dean of Research in Charge already. I am requesting Professor L.K. Babu sir to deliver his talk on new approaches to climate resilient livestock production. Sir, please start your presentation.
Good afternoon, everybody. Hello.
Yes.
Should I start, sir? Audible?
Yes, yes. Yes, start.
Now the topic that was assigned to me, new approaches to climate resilient livestock production. And all of us, we know that climate means it is the 30 years averages of the different climatic variables, particularly the weather variables with respect to temperature, humidity, rainfall, then solar radiation, wind velocity, etc., etc. And this climate, day by day, the climate is being changed, and particularly the livestock sectors are adversely being affected by the detrimental effect of this climate. Now, under this, I have thought of to discuss certain issues, particularly to the climate change, that is a reality, the effect of on livestock, how livestock is affecting the animal, how the animal is being affected by livestock, what resources we have got, particularly on so far as the Indian livestock are concerned, the current approaches, some policies, and then I will give my conclusion. So far as this global context of livestock domain is concerned, the food and nutrition security, human and animal health, then poverty reduction, growth, natural resource management, all these aspects, particularly they are being affected due to growth in human population. And when there is increase in human population, ultimately it is giving some effect towards the environmental degradation. And because of this urbanization and industrialization, our land is also being limited. And ultimately, all these respects, they are giving threat to our climate. As a result, the temperature is rising, particularly 1 to 3.5 degrees centigrade. It is expected that it will rise towards the end of this 21st century. But we have to go for food production need to increase by about 60%. And because there is to feed the world human population to hit about 9 billion by 2050. So for the livestock sector is concerned, from livestock sector, average 17% of the food calorie that is obtained, more than 1/3 of the protein of the human diet is obtained, particularly the cattle, more than 1 billion ton of grain they are consuming every year. And this consuming almost 60% of the global biomass, and it occupies 30% of the world land surface and 70% of the agricultural land. This so far as the smart agriculture is concerned, that it has got certain components that are to be touched. I want to discuss these things, particularly sustainable increase in productivity is to be there. And then resilience automatically that adaptation is there. There is a reduced greenhouse gas production, enhances achievement of national food security and development goal. When you talk about resilience or a resilient animal or resilient capacity, means it is an animal, it refers to the ability of an animal to recover its normal biological function after it is being exposed to several adverse climatic condition or adverse stressful condition. Now it is one it is either a process. It is not one individual trait, or it is not a trait actually. This resilience is not a trait. It is a process how the animal adjusts itself or adopt itself to different conditions. This livestock is being exposed in two different ways. One is that livestock is contributing what it is contributing to the climate, how the climate is being affected with the livestock. And second is how the climate influencing the livestock. So two things are there. And Dr. Kamara recently, he was discussing a vivid discussion he was having. So far as particularly with respect to reducing the greenhouse gas emission from livestock, several strategies, several things he has already told recently, starting from 2 to 3, just we are watching that one. So that is the livestock contribution towards the climate. And so far as the livestock, what the climate is influencing, there is a reducing effect of climate change on livestock production. So both these two aspects are to be equalized so that there will be optimization in livestock production. Here one chart, one graph I want to show you here. The hottest year in the globally, it was 2017 was the hottest year, and so far the hottest decade is concerned, probably 2010. After 1990, then 2010 was the hottest year, hottest decade. The climate change, its impact in India, particularly there is a warmer season, and the average temperature is rising. Already 2 degrees centigrade it has increased. There is increased annual precipitation, lower frequency of the rainfall, very erratic rainfall that is occurring in India. Somewhere there is excessive rainfall, somewhere there is no rainfall. And so far as the cyclonic disturbances is concerned, there is increased intensity. Earlier the cyclone was occurring in every 10 years, 15 years like that. But it has become a regular practice, particularly for Orissa, for West Bengal. If you can recall the past, there was super cyclone in 1999. Then Phylin was there in 2013, Hurud in 14. Then Titli in 2018, then Foni in 2019, and recently Amphan was there in 2020. So there is a increased risk of the storm, then the sea level is also rising. The fresh water supply is also high variability is there. Particularly somewhere there is flood, somewhere there is drought. Similar things are happening because of this impact of climate only. The farmers will bear the burden of the climate change. These are the 12 states that have a distinctly highly sensitive to climate change. Climate change means a degree of being affected by climate-related stimuli, climate variability, and the frequency and magnitude of extreme events. Mostly the northwestern parts of the country, our country, they are more sensitive. It has been highlighted with the red ink, very highly sensitive. The eastern, northeastern, northern and west coast, they are relatively low sensitive. These are the different 21 states have distinctly highly exposed climatic changes. Climate changes risk is more in these 21 states. And these are the 17 states. They have districts with low adaptive capacity to climatic change. Particularly very low adaptive capacity is there in eastern and northeastern states. This is about the impact of climate change on livestock. So the climate is influencing the livestock, particularly through different climatic variables. The most important one is increase of the temperature. And as a result, there is a change in influence with respect to water, then with respect to...
ये तस्वीरें सब आप देख सकते हैं यूपीएससी क्लियर करने के बाद करनाल का बेटा आज पहली बार जब अपने घर पहुंचा है तो किस तरह से उसका स्वागत किया जा रहा है। करनाल का बेटा विक्रम दैया जिसने यूपीएससी क्लियर किया है और उसके घर पहुंचने पर उसका जोरदार तरीके से स्वागत किया जा रहा है। हम आपको बताना चाहेंगे विक्रम दैया जिसने शुरुआत से दयाल सिंह स्कूल मेन ब्रांच से पढ़ाई की, उसके बाद आरएस स्कूल से पढ़ाई की और आज करनाल
Hello? 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 Dr. Das?
Yes, sir. Yes, sir. Now we can start. Yes, sir.
Now, this when there is because of this increase of temperature, there is influence with respect to the water, with respect to the forage, vegetation, with respect to production, particularly the high producing dairy cows, they are being much more affected. The meat production is also being affected. Similarly, the reproductive traits, they are also being affected, including the health status of the animal is also being affected. And because of this increase in of carbon dioxide, several things are there that all of us were knowing. And the combined effect of increase in carbon dioxide and temperature that affects the forage, particularly the composition of the pasture, shifting seasonal pattern, changing optimal growth rate, changing availability of water. Similarly, the precipitation has also got a direct effect, particularly long dry season, decreased forage quality, forage growth, and this forage and this precipitation and temperature combined they influence the disease. Now these are the different pathways of impact of climate change on livestock, particularly variability in rainfall. Because of the rainfall, there is effects towards the animal. Shortage in drinking water may be there, some diseases might be there. Forages and feed crops, they are being affected. Yield may be decreased. There may be changes in pasture composition, change in production system, labor force and capital, alter human and health, and resources allocation to livestock. There will be decreased productivity. Migration of labor is also there, and that is because of this climate change. The laborer, they are not getting employment, they are not getting their livelihood. So ultimately, they were being compelled to move from one place to other place. That also is coming under the climatic changes. So climate change impact on cattle, some production parameters are affected, some to overcome that one, some adaptive physiological, morphological, behavioral, physiological, neuroendocrinological, some shifting of some blood biochemical or molecular aspects are to be done. This is all about the effect of climate change, particularly on growth. Under the growth, I don't want to enter into the details with respect to milk production. Not only the total yield, but also the composition is also being affected, particularly with respect to the different nutrients or different components of the milk, constituents of the milk, lactose, milk fat, solid not fuel, protein, etc. They are also being influenced. The reproductive parameters are also being influenced due to impact of climate, particularly with respect to fertilization, consumption rate, then folliculogenesis, spermatogenesis, etc. They are also being influenced. Some adaptive changes like respiration rate, rectal temperature, cortisol level, heat stock may be there, some thyroidal hormone changes may be there, and finally the disease occurrence, particularly the vector-borne disease, then some pig-borne diseases might be there. Particularly in high rainfall or in hot and humid area, the infestation with the pig infestation is a common. So under such a situation, filariasis, babesiosis, and other blood pathogen parasites are there. But the Indian livestock, they are very valuable, and they are our treasure. The adaptability to low input managemental system is there. They can adjust themselves to very adverse climatic conditions. They can withstand to drought, famine, lower basal metabolic rate. So there is a alteration in body structure. They use to adapt themselves by altering their body structure. The traits of inherent resilience and adaptive capacity are a long legs, short hair coat, higher sweating rate, large surface area, body conformation, higher capacity for maintenance of heat balance, etc. And as I've already told you that they are a little bit more immune compared to the other exotic animals, and disease resistance is more with respect to this filariasis, one disease, babesiosis, and other diseases. Now there is ultimately some morphological adaptation Morphological adaptation, we can see here particularly to Vechur, it is the smallest cattle breed, but although it is very short statured, because of its adaptability, it can withstand that Kerala and doing a very good result, giving very good result. It is extremely adapted, low feed requirement is there and less water requirement. So almost all Indian cattle, they are adapted to this type of morphological adaptation or towards climatic changes. And that is why everybody giving emphasis for conservation of native germplasm. One example I want to give you here, the best ongole that is found in Brazil. But in our country, particularly in Andhra Pradesh, the animals are no doubt adapted, but the performance is not to that extent what they are outside. So that is the aspects we have to think. Why our own native animals, they are not doing excellent in our climate, and whether they are when they are brought to outside, they are doing excellent. As far as the gear is concerned, one gear in Brazil, the average lactation milk yield, what that is there in Indian condition, we are telling it is 2,000 from gear cow in one lactation. But in Brazil, the record says it is even 3,500 kg for lactation, with the world record, what I was observing, 17,120 kg. Now, the Indian cattle, particularly so far as the extreme climatic variability is concerned, they used to adapt themselves up to even 49 degrees centigrade. Some examples I've given you about the animal starting from Kankri, Sahiwal, Tharparkar, Rathi and Nagori, Haryana, where there is a wide range of variability of temperature, still the animals they used to survive. The climate resilient technology, particularly climate smart housing system, nutritional intervention, pasture management, water resource management, genetic approach for climatic resilience, and disease surveillance management. These are the different aspects that are to be touched, that are to be given emphasis, that has to be taken care of, so that the animal will adapt himself and we can get more of the resilient animals we can develop. So this is all about one chart, actually, the pathways for climate resilient livestock, particularly through nutritional modification, particularly through housing, then genetic modification, and through disease control and management, particularly with respect to animal health. So for the shelter management, this thing all of us we are knowing. However, the proper grouping of animal must be there, adequate loafing area, feeding facilities must be there, 24 hours water provision, and there should be adequate water provision for showering or splashing. That is essential, particularly during the hot weather. The west side of shed to be protected with side cover, gunny bag may be used, curtains may be used. Sometimes the roof may be extended further with a setting material, and height at eaves that all of us we know. It should be maybe 2.5 meters, something like that. Roof painting may be there, and that white outside should maybe of white, inside maybe of black to absorb the heat as blackboard. Then attic or false insulation may be there, so that there will be reduction in the inside temperature. And particularly, most of the farms nowadays, they are going for ventilation by providing roof ventilation or ridge ventilation by constructing semi-monitor type or monitor type of housing. Thereby, the hot air will go from the shed from the top. This is an example of a monitor type of house. Loose housing system in tropical area may be there, and everybody we have to agree with this fact that the asbestos roofing is desirable. Galvanized iron or aluminium, they are less satisfactory. The shelter material may be having low radiating coefficient, making their surface reflecting, that I've already discussed this thing. Constructing the shelter property and thatch roof, particularly palm leaf, coconut leaf, straw, grasses, etc. may be used. And this may be in a village condition, no doubt. Of course, it has got some demerits of fire hazards, rat menace. However, for low-cost housing, this cannot be ignored, and particularly to reduce the inside temperature of the shed. Still, the microclimatic modification may be there. Microclimate means it is within 8 meter of the radius where the animal is directly being exposed. The major principles to ameliorate the climatic stress to minimize the overcrowding, minimize time in the holdings. These are these microclimate modifications, some of the photographs and these things already I have discussed. So far as the ventilation is concerned, this thing also I have already discussed, particularly ventilation at the ridge region to provide more comfort to the animal as the hot air will go from the top side. Besides that, some sprinkler and fan may be used to cool the animal. Showers and pools may be there, particularly for wallowing purpose. Pool may be constructed and shower may be constructed so that the animal will, whatever the temperature that is absorbed by the body, that can be dissipated and the animal will remain under thermal comfort. High pressure fogging system, mechanical cooling, so several things or several respects that are to be given emphasis, particularly to reduce the temperature load of the animal. Evaporating cooling system, use high pressure fine mist can be given large volume of air to evaporate moisture and cool the microclimate. Sprinkler and mister. Different ameliorative methods used by the farmers. Some of the steps that I have shown here, particularly growing vegetation over the roof or by use of fan, by misting, or even in the village area or in the farm itself by utilizing the gunny bag, sprinkling water so that the cool air will blow and thereby the animal will dissipate their body heat and will remain under thermal comfort. This is sprinkling unit and fan. Second aspect that is to be given emphasis is feeding management. Increased frequency of the feeding may be there, particularly during summer season, during daytime, restricted grazing may be there to the animal, if at all they are allowed outside for the purpose of grazing. Time of feeding may be cooler part of the day, adequate feed bunks or feeding space, so that all the cows, they can take the feed at a time, providing sufficient green fodder. And all of us, we know that the balanced forage mixture, if at all it is available, that is to be given, maybe 2 parts cereal fodder with 1 part of leguminous fodder. Total mixed ration, particularly the dry fodder with the green fodder, as I have already told you, soaking of the concentrate in equal part of water for 20 to 30 minutes. It helps in better utilization of nutrient, and simultaneously the dustiness of the concentrate also will be reduced by utilizing the soaking in water. Night grazing may be allowed, particularly in summer season. The nutritional management, proper balanced nutrition, the roughage concentrate ratio 2/3 and 1/3, use of quality feed, reducing fiber content in the feed, because more the fiber, more will be the heat load, more will be the heat load in the body. Increasing the dietary fat content, reduce the metabolic heat production. Artificial lighting would result in increased consumption at the night hours. Excessive concentrate feeding leads to acidosis, and the associated problem may be there. Vitamins like A, E, zinc, selenium, etc., or selenium-rich yeast help reducing the impact of heat stress, particularly that improve milk quality and cow health. And this vitamin E improves the antioxidant status and lowers the incidence of mastitis, metritis, retention of placenta, and other diseases, particularly during heat stress. Lush green fodder may be given, but lush does not mean that the fodder to be cut or harvested in very early stage, particularly in case of hybrid Napier, because of this high oxalic acid content. The farmers, they used to complain that there is reduction in milk yield, and because hybrid Napier contains considerable amount of oxalic acid in early stage of growth, and if it is cut before 1 meter height, or subsequently at least 40-50 days interval to be maintained. Otherwise, that oxalic acid poisoning may be there, thereby reducing milk yield. Improved pasture management, replacement of native grasses with a higher yielding and more digestible forages, intensification of pasture production through cutting regime, improved pasture quality through nitrogen fortification. Several steps are being scientists they have developed how to improve the quality of poor quality refuges. Almost tolerant fodder varieties that may be developed, and year-round fodder production should be there. The animals to be given year-round fodder production, so that the animal is not the animal which will not use excessive amount of concentrate, and the animal can be maintained by the green fodder. Thereby, the cost of the production also will be reduced. The water requirement, cool drinking water to be given, particularly in summer. It is desirable to have the temperature at about 16 degrees centigrade. Under intense heat, injection of large volume of water provides comfort to the animal by reducing the temperature of the rumen and reticulum. Then healthcare management, under this some steps that I want to discuss. Develop a comprehensive plan, particularly health and disaster reduction, to deal with the transmission of disease due to climate change. What are the diseases that is expected? How to ameliorate that situation to be given emphasis. Developed positive animal welfare, then contingency plan to control zoonotic diseases. Use vaccination, particularly with respect to foot and mouth disease, PPR, rabies, and other diseases as a control measure where appropriate. In region where disease is endemic, then in that particular area of the country, specific protocol to be maintained, specific things to be developed, so that the disease occurrence can be prevented. Improve biosecurity and animal production site, that also safeguard animal welfare. And this biosecurity is one very important aspect, particularly so far as the poultry birds are concerned. Then the transportation of live animals that may be limited, particularly in endemic area. And we, at present, we can know what about the question of transportation with respect to human being, particularly in the corona. All of us were facing the problem. Disease climate relationship modeling must be there. Statistical modeling may be done to study the effect of climate change on disease outbreak. Data collection for weather, disease outbreak. Then anthropological factors, particularly vector availability, host factor, remote sensing data. Then predict the occurrence of disease outbreak prone area in advance. If this can be done, then this disease can be prevented. And to implement the preventive measures effectively, use of use of resource particularly, and then proper livestock disease control measures must be developed, particularly with respect to vector-borne livestock diseases. Then predicting and forecasting the extreme events are a crucial component for preparedness and response to animal climate change associated with the problem. Efforts are needed to strengthen meteorological services to provide timely weather and climate forecast. Of course, the science has developed, we are getting the forecast. The primary focus of EWS should be to reduce risks to the farmer arising from drought, extreme weather events, and pest and other diseases outbreak. So for the genetic approaches for this climate resilience is concerned, selection of livestock, that is one very important aspect. And now the time is that definitely all of us, we should agree to conserve the native germplasm. And we know that the native animals, they are performing far better. Although there is extremes of climate, still the animals, resilient animals are being developed. Conservation of indigenous germplasm is a must. Maintenance of animal biodiversity. Breeding for more heat tolerant and disease resistance. Crossbreeding program to be continued, no doubt. Genetic development of less sensitive breed. Identification of genes related to thermal tolerance and genes controlling cellular resistance to heat shock. Identification of animal that are genetically superior. Then genetic selection based on milk yield and heat tolerance under local condition. Identification of genes that are involved in key regulatory or metabolic pathway, particularly for thermal resistance and thermal sensitivity. Integration of marker-assisted selection into animal breeding system. This is one new concept that can be thought of. And these are the strengthening extension activity is also one very important aspect. These are the points that are to be thought of so that whatever technology that is being generated that can go to the land itself, particularly from the laboratory. These are the strategies to improve livestock production, particularly strengthening and forecasting capacity, whatever that I have told, something I have briefed here. And in the concluding remarks that I can say here, breeding more productive animals, improving the diet so that animal produce more protein with less feed and lower emission, that methane emission Dr. Kamara sir was discussing. Better manure management, this is also one important aspect, particularly maybe through biogas technology, maybe through composting, or maybe through other utilization. Recently, we must have seen how the people they are utilizing the cow dung, particularly in other aspects. Better herd management to improve the output, including better herd health management with less resilience on antibiotic. Because particularly in poultry also the antibiotic feeding has been completely stopped. So better management of grassland, this is also one of the very important aspect. And particularly this aspect also to be given emphasis. Thank you very much. And I pray Lord Jagannath to bless everybody, particularly to stay healthy, particularly in this COVID-19 pandemic. Thank you very much.
Thank you, Babu sir, for your nice presentation. Sir, please stop presenting, sir.
Okay, sir.
Stop sir, you have presented very pleasantly the different aspects of this climate stress, particularly our native breed also. The threats which you have mentioned here is very important. And the management strategy, nutritional approach, the genetical approach, administrative management system, what you have suggested for the mitigate the situation, the issues, is very important for the participants also. Now I am requesting Dr. Patro to please place some questions for discussions. Dr. Patro, please.
Thank you, Professor Babu sir, for your excellent deliberation on the climate resilient animal production technology. We have received few questions from the YouTube channel. First question I want to ask that, is there any humidity measure protocol?
Sir?
Is there any humidity measure protocol?
Excuse me?
Is there any humidity measure protocol?
For measurement of humidity protocol means the same wet bulb, dry bulb reading, whatever it is measuring the same thing. Protocol means for measurement of humidity, sir. One is
asking humidity measuring protocol.
Protocol that is not there. The same dry bulb, wet bulb thermometer reading we are recording to measure the humidity.
Okay, thank you, sir. Then I'll go to next question.
Right.
Humidity causes also stress, and heat also causes stress.
Right, sir.
If yes, in hot and humid area, how sparkling is going to help?
Sir,
how it is going to help sparkling?
You see that water splashing, mist or things of that nature, that I have told that is not confined to the humid climate only. There are certain places in India where the daytime temperature increases up to 44, 47, 48, 49, where the climate is dry. Under such a situation, if we are going for splashing, water splashing, provision of meat, mist or sprinkling, that ordinary body temperature will go, but that may not hold good so far as the very extreme humidity condition is concerned with respect to Odisha, West Bengal, like that, because the high temperature and high humidity, they create further stress, and the animal will not get one conducive environment to dissipate the body heat from the animal. But there are in the particularly in northern belt that your sprinkling using of mist, fodder, etc. that will hold good, and that is being practiced also.
Okay, thank you, sir. Sir, I have another one question. India has the greatest genetic resources of livestock.
Right, sir.
So how do you find this opportunity? How do you find this opportunity to design a climate resilient animal production? Because our India has many genetic resources. So how do you design? How do you plan? How do you find this to design a plan
Sir, the important
for
aspects is
climate
that
resilient animal production?
the important aspects is that the conservation of native germplasm is to be given emphasis, and then better method of upgrading may be there, in particular in local area. Better type of animal may be utilized from among that particular breed, so that the breed can be conserved, and without going for rampant crossbreeding or something like that, we have to conserve our native germplasm, and we have to utilize the dung in different way that will not going to pollute the environment, thereby increasing the greenhouse, particularly with respect to methane and other. So conservation of native germplasm side by side, utilizing the waste product of these animals in efficient way, thereby reducing the temperature and other things that affect the climate ultimately. Suppose unnatural fermentation will be there, the animal will move here and there and they will defecate, then automatically from that again methane will be coming, and then again that will increase the temperature. So that type of the dung may be utilized efficiently, or excreta may be utilized efficiently, thereby also the temperature can be reduced. And another one point, without going for this provision of staple feed like paddy straw, what is being done in coastal belt, particularly in Odisha and West Bengal, that increases the thermal further heat load of the animal. So further cultivation is also to be given emphasis, thereby this methane emission can also be reduced.
Okay, any more question? Dr. Papa is there?
Yes,
Okay,
sir.
sir. Thank you, sir.
Is there any more question?
Maybe I can ask one more, or just maybe we are late. Okay, then I will ask one question. So what is your opinions to preserve the? Okay, I think you have already answered that. So I will not go further. What is your views about climate smart agriculture for the Northeast India? Because what is your views about climate smart agriculture for the Northeast India?
Particularly in northeastern states, our state, mostly the animal they used to cultivate rice, and the paddy straw they used to utilize that paddy straw rampantly for this growth of the animal. So hardly the animals of northeastern state they are getting good quality fodder. So definitely, if anybody interested to go for a dairy farm or to have at least some animal, then I can give one message that at least daily 4-5 kg of green fodder the person to be able to feed the animal without going for this utilization of paddy straw. And another important aspect is that, particularly in hot and humid climate, the tick population will be there more. Thereby, the blood pathogen diseases are more, particularly in hot and humid climate. So some measures to be developed so that this population can be reduced, particularly the blood pathogen diseases that can be reduced, particularly in your northeastern or in coastal area, particularly in Odisha, West Bengal, Assam, like that.
Okay, thank you, sir.
Okay, thank you very much, sir.
Thank you, Dr. Patro, for your nice presentation of this lesson, the questions. And thank you, Dr. Babu, sir,
Okay,
for
sir.
your nice deliberation and discussions. And I think our participants also get a specific guideline about the climate smart resident animal livestock production system from the angle of all about our veterinary and animal husbandry area, which you have covered in your discussions, starting from the parasitic infection, management strategies, nutritional strategies, everything you have covered in your in the whole lectures. So it's a very beautiful lecture, sir. Again, we are again congratulate from our organizing committee for your nice presence and deliberations. Thank you, sir. Thank you, sir.
Thank you very much, sir. Thank you very much. Thank you.
Okay. Now already we are 20 minutes late from our scheduled time of today's program. This is our third session, the last session of today. This will be the fifth session of this workshop. And
thank you, sir. Thank you, Dr. Das. Thank you, Bharat.
Yes, sir. Okay, sir. Okay, sir. Thank you, sir.
Okay.
Thank you, sir.
Thank you.
Just one announcement that today the feedback link will be available during this session. You will fill in during before the end of this session. Otherwise, you may link the copy and can send it later. We will take you today. Okay, now we will start our fifth session. Our speaker is Dr. Deepak Banerjee. Dr. Deepak Banerjee graduated in veterinary science from West Bengal University of Animal and Fishery Sciences in 2006 and did his MBSc in 2008 and PhD in 2011 in animal physiology from National Dairy Research Institute, Karnataka. After a brief spell in Anand Agriculture University, Gujarat, as assistant professor, Dr. Banerjee joined as the assistant professor in the Department of Veterinary Physiology at West Bengal University of Animal and Fishery Sciences in 2011. He has published 40 peer-reviewed research articles in international and national journals, 2 book chapters, and several invited papers and manuals. Total citation of published article of Dr. Banerjee is 426 and H index is more than 10. He has received SAPI Young Scientist Award in 2016. He mentors 2 postgraduate and 1 PhD students. He is an excellent teacher and brilliant researcher. His research areas are mainly focused on understanding the molecular mechanism of heat stress, adaptability of animal in changing climate, neuroendocrine control of fertility, etc. Right now, he is involved in research pertaining to adaptation of animal in coastal region of Sundarban. He is young, energetic, and a keen precursor of academic excellence. With these few words, I am inviting Dr. Deepak Banerjee to deliver his lecture on impact of climate on livestock and poultry production in Sundarban. Dr. Banerjee, please.
Thank you, sir. Am I audible?
Yes, please.
So my slides are here.
Yes. Slide also visible. You are audible. Please.
Okay, sir. So thank you, sir. Thank you very much. First of all, I will thank the organizer for giving me the opportunity to present before you the very important topic, that is impact of climate on livestock and poultry production in Sundarban, and share my views on this climate change issue in Sundarban. So first of all, I'll come to this Sundarban. So Sundarban, it is the largest mangrove forest in the world. Total area is about 10,000 square kilometer. It is formed by the confluence of three rivers, Ganga, Brahmaputra and Meghna river in the Bay of Bengal. The term Sundarban came from the name of the tree Sundari, which is largely found in this forest. UNESCO declared Sundarban as a World Heritage Site in the year 1987, and it was designated as a Ramsar site in 2019. Sundarban mangrove forest. The total area of Sundarban mangrove forest is 10,000 square kilometer, of which 60%, that is almost 6,000 square kilometer, is in Bangladesh and 4,000 square kilometer in India. The two districts of West Bengal, that is South 24 Pargana and North 24 Parganas. Almost 19 blocks are there in Sundarban. The total population is 4.37 million according to the census of 2011. Total number of islands are 102, of which 84 islands are inhabited by human and 48 islands are forest. It is the only mangrove forest in the world which is the home for the majestic Royal Bengal tiger. Sundarban ecosystem is a natural nursery for the fish, and millions of the people depend on for their livelihood on Sundarban. Sundarban is very much famous throughout the world because its largest biodiversity. It is the largest biodiversity of mangrove plant on the globe, characterized by very dynamic environment due to the effect of tide, flooding, salinity, and cyclone. Sundarban comprises of total 350 species of plant, 250 species of fish, 300 species of bird, beside numerous number of phytoplankton, fungi, bacteria, zooplankton, invertebrate, reptile, amphibians, and mammals. The Sundarban has been extensively exploited by the human for their collection of timber, fish, and fodder. So coming to the climate of Sundarban. The climate of Sundarban is generally very soothing and pleasant. The mean annual maximum temperature is around 34 degrees centigrade and minimum temperature around 20 degrees centigrade. The rainfall is extremely high in this region. Average annual rainfall is around 2,000 millimeter. High humidity throughout the year, around 80% due to the proximity of Bay of Bengal. The weather is almost always moist and with the humid air from the Bay of Bengal blowing constantly. Storms are very common from May to November, and the area is vulnerable for cyclone accompanied by the tidal waves. According to the IPCC, India has been identified as one among the 20 most rich countries with sea level rising. And the number of cyclone is also increasing day by day. Total 15% projected increase in the intensity of tropical cyclone, which would significantly enhance the vulnerability of the population living in the cyclone-prone coastal region of India, especially Sundarban. Major climatic threats. The most important climatic threat in the Sundarban is rising sea level, increase ambient temperature, rise in water salinity, increase in the number of cyclone, and impact of the monsoon. So rising sea level is very dangerous and threat to the Sundarban area, and the sea level are rising much faster along the Sundarban coastline. Water of the Bay of Bengal have been rising at twice as fast the global average. So you can see that is the average sea level rising, that is the graph showing the average sea level rising throughout the world. And you can see that is increasing the year after year. And if you say, some of the people is saying that what is the danger if this sea level is rising 3 centimeter or more. But you can see that is the angle between the sea level and the coastal land is almost 0.1 degree. So if the sea level is raised 3 centimeter, so what will be the effect? Then it will flood or it will immerse the land up to 65 kilometer inside this coastal region. So that will affect the people who are living nearby the coastal region. So I'll give an example. This is a picture taken in 2014. This is a picture of primary school taken in 2014 in Sundarban, that is Sagar Island of Sundarban. And this is the picture of same primary school taken in November 2017, 4 years later, and it is totally consumed by the rising water level of the Bay of Bengal. So in recent past, 3 islands, that is Lohachara, Bedford, and Superifanga, these are the 3 islands completely submerged under water. And another highly populated island, that is Ghoramara, experiencing severe erosion and aerial loss. So 60% of this island, Ghoramara, is already submerged under water, and 40% of this land is remaining. So earlier the population was around 40,000. Now the population is 3 to 4,000. So according to the IPCC prediction, the region of Sundarban, that is containing, in case of West Bengal as well as in case of Bangladesh, the 150 million people by 2050 will become climate refugee. That is a new word come, that is climate refugee, and that that coastal region, those who are remaining in the coastal region, they will become homeless. So this is a picture of Ghoramara Island. Now it is called a vanishing island. So along with this increase or rising sea level, the increasing number of cyclone are also there. So number of cyclone, if you will see, that is a number of cyclone throughout the different state of India having the coastal region. You can see that is the number of cyclone is the highest in case of Odisha, then Andhra Pradesh, Tamil Nadu, West Bengal, Gujarat, Maharashtra, and Kerala. This is a data from 1891 to 1954 and 1955 to 2017. But if you see, there is another graph, the events of severe cyclone across the Indian state having coastal region. Severe cyclone is higher in West Bengal in comparison to Odisha, and it is the highest in Andhra Pradesh and Tamil Nadu. So in recent past, we have seen 3 devastating cyclones, that is Ayla in 2009, then Bulbul in 2019, and Amphan in recent Amphan in 2020. This cyclone has done a devastating loss in Sundarban. Now we are coming to the importance of the livestock and poultry rearing in livelihood of Sundarban. So already I have discussed, that is the salinity of the Sundarban area is increasing day by day. That's why the salinity of the soil is also increasing. So this fertile land become unfertile. So agricultural land is decreasing day by day. So agriculture in some of the island is very difficult nowadays. So majority of the island people are resource dependent and wage earner and self-resilient. So most of them are depend totally on the Sundarban forest for their livelihood. So they are dependent on holly collection, then collection of wood from the Sundarban forest, and fishing from the Sundarban. But these all activities are prohibited according to the government rule, and there is a risk from the attacking by the tiger, by snake or crocodile. So livestock are one of the important resource for the livelihood development in Sundarban in this vulnerable climatic situation. Because of this livestock, the requirement is very less, that is input is very less. Along with this, those the land which is highly saline, that is not ready for the agriculture purpose, that can be used for the livestock purpose, livestock rearing purpose. So if we go to the livestock rearing in the Sundarban, the 2 very important breed, that is Black Bengal goat and that is Garol sheep. They are very famous in Sundarban area because they are originally also Sundarban area. They are highly prolific and they are highly adapted to this condition, and even they are disease resistance. Then in case of large ruminant, that is cattle and buffalo are seen, that is crossbreed cattle are reared in Pathor Pratima, in Namkhana, few of these blocks they are rearing, there is crossbreed cattle. In case of poultry, backyard poultry farming is very famous in Sundarban area, and RIR or Rhode Island Red is very famous. Along with this broiler bird, and that is broiler farming also common in Sundarban. Now turkey farming is increasing in Sundarban. So goats in the Sundarban. Goats in the Sundarban contribute greatly to the agrarian economy, where the crop and dairy farming are not economical due to the saline coastal region. The breed, that is a goat, and along this Black Bengal goat are vulnerable to rainwater. and water logging condition, but yet they are adapted to this coastal region of Sundarban. So in Sundarban, there is a Black Bengal goat is producing good quality. That is, Black Bengal goat is very famous for their skin and meat. And in one behavior you can see, that is in Sundarban, goats are grazing in the marshy land and water land that is generally not seen in other parts. Along with this, the housing requirement is also less, because most of these farmers, they are keeping their animal along with them in their own house and require zero input. They are very feed conversion ratio is very high, low water requirement and disease resistance. So these are from picture from the Sundarban grazing land of Sundarban. Then this is a peculiar type of housing in Sundarban. This is the macha system to keep away from there any type of the water logging condition, maybe flood, or there is even they will protect them from the snake or from the parasitic infestation. So now Garol sheep. Garol sheep also a breed that is of sheep, which is also the origin from the Sundarban. This is the breeding track of Garol breed. Garol is a micro sheep of India, generally found in the Sundarban area of 24 Pargana. This is best known for the biannual lambing, high prolificacy rate, high mothering instinct, adaptability to the mud, saline, as well as hot and humid condition. They are resistant to many different types of the disease. And even in this picture, you can see that sheep also graze in the marshy land and water land. So owing to their high fecundity rate and ability to thrive in low quantity of forages and agro byproduct, these animals constitute a major source of income for the owners in the Sundarban. Then backyard poultry farming. Backyard poultry farming is very famous in Sundarban, and one project, that is Rashtriya Krishi Vikas Yojana or RKVY project, that was already completed in our department. That is principal investigator was Dr. P.K. Das, and one finding was there that coastal zone is the best agroclimatic zones for backyard poultry farming in the West Bengal. Because of this climatic condition of this Sundarban helps this this breed of this poultry, that is Rhode Island red, for their growth and their production. So along with this Rhode Island red, already I have told that the broiler bird is also rearing broiler bird is also common. Now there is a broiler farming is also seen in Sundarban, and along with this that is the turkey farming is also increasing in Sundarban area. Duck farming is also seen in Sundarban area, that is integrated duck fish agriculture farming. Duck and poultry manure are generated and it is used for the organic farming system, and that also helps in the development of women empowerment. So now the effect of climate change on livestock and poultry production. So our earlier eminent speakers have already told a lot about the effect of climate change on livestock and poultry farming. So I am not going into details. So one thing I will tell, that the climate change is a global phenomenon, that not only India is affected by the climate change, but whole world is concerned about this climate change. However, its manifestation and impacts are locally. That means that local manifestation is there, and impact of this climate change is varies from the place to place, from different locality. So that's why for formulation of any strategy, that may be mitigation strategy or that may be adaptive strategy for the government, so requirement of the field level data is very important. So India, like India, it's a large country, the field level data is very important for their formulation of any strategy. So it is the Sundarban is the richest biodiversity, so it is a hot spot for the vulnerability and climate change. So already my earlier speaker has discussed all about this impact of climate change on livestock. I am not going into details, but one thing I will tell, that is the most important, that is the shortage or scarcity of forage and fodder in the Sundarban area, because agricultural land is decreasing day by day in the Sundarban area. Along with this, grazing land and that is a grassland is also decreasing. So that's why it is very difficult to feed the animals or livestock the green fodder or forages. So even due to the frequent different types of the flood, then cyclone and high tide, what is happening, this even this soil is deficient in different types of the mineral, and that is also depicted in the composition and food and fodders. So if the forage and fodder is deficient in fodder and forage is deficient in these different types of the mineral, then ultimately that will affect these animals for their growth, their production. So again, and the next thing is the decrease in forage and fodder quality, and along with this, there is a scarcity of water. That is drinking water is also there. So forage and there is a drinking water scarcity is higher during the time of summer month, and after any type of the natural calamities. That natural calamities may be that is flood, that may be cyclone, that may be any type of the high tide. So after that, any type of the natural calamity, it is very difficult to feed our livestock. So I'm not going into details effect of heat stress on livestock, which is already discussed. So impact of livestock and ecosystem. So the global demand of non-irrigated water is increasing day by day. So increased temperature will ultimately cause lignification of the plant tissue, and that lignification ultimately causing the reduction in the digestibility of this plant part, and that ultimately causes reduction in the livestock production. Grazing land also decreasing day by day, and along with these different types of the natural calamities like cyclone, that like flood, and like there is a high tide that is frequent in case of this type of coastal region, that also increasing. And after this monsoon, the vector-borne diseases also increased in this particular area, and even due to this shortage of this food and also this low quality forage and fodder, the immune status is decreasing in the particular areas of the Sundarban. So if we go, that is the effect of high salt in the animal. So there are lots of literature are there which tells that the drinking the saline water or consumption of feed or fodder with high salt content will cause some of this literature is telling that water consumption will increase, and some of this literature is telling that water consumption will decrease. But most of this literature is telling that the increasing salinity will cause the feed intake, that decrease in feed consumption, decrease in growth rate, decrease in meat quality and carcass quality. So last few years we are working in the Sundarban, and we have done some of the experiment in the Sundarban. That is, we have taken different types of the sample from different island of the Sundarban throughout the year in different season like spring, summer and winter, and we have estimated different hematophysiological different parameters, and we have compared this with the control like that is goats of Kollani, that is IVRI Eastern Region Farm in Kollani, that we have kept as a control, and we have compared it with the goats of the Sundarban. So what we have seen along with this different parameter, we have seen that is the serum sodium level, though they are though this salt content or sodium content or chloride content is very high in feed, soil and water, which we have estimated, and water TDS is very high, then soil and feed is also in high amount of the containing high amount of the sodium. But in case of animal goat rearing in the Sundarban, they are having the normal level of sodium or salt, that is sodium or chloride content. Though during the summer, due to shortage of this water, that is to some extent increased, but in other season, it is comparable to same like that of the other control goat. But same things, then we have estimated the different minerals along with the sodium content in urine. So now we have seen that is the urine, the content of sodium in the coastal region, the goats of the coastal region is higher in comparison to that is control group. That means, and even we have seen that is the total that is the volume of urine is also higher, and specific gravity of urine is also high. So we have come to a conclusion that goat reared in the coastal region can withstand the salinity. They are already adapted that particular climatic condition without much alteration in the homeostasis. So that is homeostasis that even that is not to some hampering their liver or kidney functions. So another things that is our observation in Sundarban, that is observation we have seen, that is the winter is more stressful in comparison to the summer. That was depicted by the cortisol level and that is thyroxine level were higher during the time of some winter in comparison to summer month. So we came to a conclusion that winter season is more stressful in comparison to the summer in Sundarban region, that is goats reared in the coastal region of the Sundarban, in comparison to our control groups which reared in the Kollani, that is in Nodia farm. So these are the pictures we have taken. This is the picture of this Sundarban. We have taken the samples from the different islands of the Sundarban from goats. So adaptation, now we are coming to the adaptation strategy by the livestock farmers. So what are the different adaptation strategy which are already taken by the farmer or which will be taken by the farmer, which is very important. So adaptation strategy, first and foremost, is the nutritional strategy, because most of these animals reared under Sundarban are nutritionally deficient. So because of this addition of extra concentrate, then provision of the mineral supplementation and feed additive, use of additional crop residue or hay, and changing feed and that is a feeding schedule and grazing time. So last day our speaker have already discussed that during time of summer month, if we'll change this feeding schedule or feeding time, grazing time, that will help them to protect them from the heat stress. And now there is a drinking water, provision of drinking frequent, clean and fresh drinking water is very important during the time of summer month or after any type of the natural calamities like after flood, like after cyclone. Then reduction in herd size. It has been seen that after the cyclone of Ayla, that a large number of farmers are shifting from large ruminant to small ruminant rearing, because the risk in the small ruminant rearing is less, and small ruminant like sheep and goat are least affected by these natural calamities or changing climate change. So they are shifting from large ruminant to small ruminant. Then they are selling few of this animal and they are reducing their herd. Now these farmers are not interested to keep large number of animals. They are keeping small, very few number of animals. Then reduction in the stress. So our earlier eminent speaker have already discussed how to reduce the stress in the animal, like center management, like additional washing, sprinkler, then changing in microclimate of the animal. I am not going into details. Then breed management. In Sundarban, already government and our university and even there is an NGO are promoting that interest in the local breed, like in case of Black Bengal goat, like that is a Garol sheep for their rearing, because they are highly resistant to different types of the disease and they are most tolerant to this climate change. Then health care for the animal. Healthcare facility is very important. There is a timely vaccination, provision of extra healthcare to the livestock, because after any type of the natural calamities, it is very important. During the time, spread of different types of the disease is very high, and after this monsoon season, it's very high. And using mosquito net, because vector-borne diseases is very high during this time. And livestock insurance, it is also very important. It will reduce the risk in case of farmer. So what is the emphasis to be taken, required? So emphasis to be taken by our government or by our university and different types of the NGOs, and some of the NGO or government organization is already working in the Sundarban. That is, first one is the lack of our awareness in the farmer regarding the scientific livestock rearing. Then unavailability of the quality fodder seed which will grow in the saline soil. So nowadays Indian Council of Agriculture Research and different agriculture university, they are developing some of this fodder feed, and there is a fodder there that can be grown even saline soil also. So this provision of this type, the seed of that type of fodder to these farmers is very important. Then lack of awareness regarding vaccination among the people. people now, our university, different projects are there. That is also, that project is like AICRP project on board. They are also working on vaccination regularly. They are doing vaccination there. The Tagore Society of Sundarban, they are working on that. Then controlling of broiler marketing. So marketing, it is a very big problem for the Sundarban, because this island, their transport facility is not so good. Because of this, middleman is there. So that farmers are facing problem for marketing milk, or marketing meat, or marketing poultry, or even egg. So middlemanship is there. So that's why this marketing should be required. Now government of India, government of West Bengal is now creating that is Sundarini. It is a project by the government of West Bengal for marketing of milk and the different egg and different products from the Sundarban. And they are producing, that is, organic milk from Pathar Pratima on different blocks of the Sundarban. Then unavailability of the quality calves, kid, piglet, duckling, chicks, and feed in different island, it is also there. And proper and scientific housing is also required. Then after that, this discussion, I will come to a conclusion that realizing the present situation in the perception of the global warming resulting to many natural calamities, the livestock perhaps the only answer in respect to the improvement of livelihood in the farmers of Sundarban. Therefore, a comprehensive approach is to be taken to improve the quality of livestock available in this area. So we have published a number of research paper on this, working on Sundarban and even goat in our department. These are the different papers we have published, already published. So this is the paper from the RKBI Rashtriya Krishi Vikas Yojana project. So will this, I am concluding my presentation. So I am very much thankful, and also I am thanking the organizer and I am very much glad to sharing the same platform with some of the eminent scientists of animal science. So thank you very much. So if you have any question, you can ask me. Thank you.
Thank you, Dr. Banerjee, for your nice presentation. You have clearly explained the different potentiality and threats of the livestock and poultry production system in Sundarban areas. And it is very particular and very pertinent for today's discussion, because, yes, sir, more than 56% population of the Sundarban areas, they are landless. So their basic source of income is basically on the livestock production. Yes, sir. Yes, sir.
Very nice presentation.
So, Dr. Banerjee, yes, sir. Dr. Banerjee also emphasized the different thrust areas and adaptation strategies for these Sundarban areas. So now I am requesting our rapporteur, Dr. Kinshuk Das and Dr. Patro. So if you have any questions, please.
Thank you, Dr. Banerjee. Thank you, Dr. Banerjee, for your clear and nice presentations on the Sundarban and livestock production in Sundarban and resilient climate animal production in Sundarban. Actually, Sundarban has a unique ecosystem with rich habitat, wildlife habitat, and it is one of the hot biodiversity area. Unfortunately, this Sundarban area is very much vulnerable to the for the consequences of climate change. So this topic is very much pertinent. In this regard, we have received few questions. So I will ask first question. As you rightly mentioned that Sundarban has high salinity. So how this then this high salinity is detrimental to the normal physiology of the animal. So in such condition, how do the animal adjust to cope up with the situations?
Okay, sir.
Can you hear?
Yes.
Can you hear?
Actually, sir, what is... yes, sir, yes. Yes,
Can
sir.
you hear? Am I audible?
Yes, sir.
Yes, Dr. Banerjee, you tell.
Okay, sir. Sir, actually, what I have told also here, in during my presentation that
Dr. Banerjee, your sound problem is coming. Dr. Banerjee, you just hold the microphone. Hold the microphone. Yes.
hello.
Yes.
Sir, now it is audible.
Yes, audible.
Sir, the things is there, sir, already which I have discussed in my presentation that there is a salt in case of Sundarban, though that is a high salinity will affect our physiology. Definitely, we have discussed in our presentation, and some of this local breed, like in case of Black Bengal goat, like in case of Garol sheep, they are adapted, and there are some physiological mechanism is there, which ultimately help their to tolerate this salt tolerance. We are keeping them their salt tolerance, but there is a limit is there. Even if you will give more, that is the water of sea water to this animal, then definitely some physiological changes will be there. So now we are emphasizing to keep the animal which are already adapted to that particular climatic condition, like in case of Black Bengal goat, like in case of sheep. And definitely this high salt content will affect their physiology. If the salinity is increasing more than if the salinity of the more feed or fodder and even the water will increase, that will definitely affect the physiology of that particular animal. And now, okay, sir.
Yes, yeah. Dr. Patra, the second question. Please raise the second question. Dr. Patra. Sound is not coming, Dr. Patra. Sound is not coming. Dr. Patra, your sound is not coming.
You have rightly mentioned that mangrove is the plant in Sundarban. Can these mangrove plants be used judiciously? Hello?
Yes, sir.
Hello?
Dr. Patra, repeat the question. Dr. Patra, you repeat the question.
Hello?
Dr. Patra, you are audible. You please continue.
Now sound is coming?
Yes.
Yes, it is coming.
Sundarban has the mangrove plants. Can these mangrove plants be used judiciously as fodders for livestock in this area?
Sir, actually, the mangrove plant,
can be used as a fodder in this area?
No, sir. No, sir. Actually,
If it
already
is used
I have.
judiciously?
Sir, am I audible, sir? Okay.
Yes.
Sir, actually, I have told during the discussion of the biodiversity, actually the number of this plant is decreasing day by day because of this human are using for their this collection of wood, for the fodder.
Yes,
Even
you are audible.
That even this mangrove is protecting the Sundarban area from different types of the cyclone. If the mangrove, the Sundarban mangrove will not be there, then it will cause more loss in the the nearby areas of the West Bengal or in case of Bangladesh. So it is protecting. So So protection of this mangrove is very important, very important. So nowadays, so that is destroying any mangrove plant is prohibited by the government. So for using this type of plant for fodder purpose or any purpose, wood purpose, it is prohibited. It is not means that can't be used. That is mangrove plant especially in case of Sundarban forest.
Okay, thank you. Thank you for nice answer. So next question is Sundarban is the home track of barrel sheep. Do you think there is special molecular adaptive mechanism for barrel sheep compared with the other sheep in low salinity area?
Yes, sir. Actually, we have done some of the molecular work on this black Bengal goat, and even later we'll do this in case of sheep also. That mostly that is in case of HSP heat shock protein, that also helps their adaptation. And now we are working some of the genes related to osmolarity regulation. Some of these genes which are helping, that is salt tolerance in case of different aquatic animal like osmotic gene. Maybe that type of gene is responsible for their high salt tolerance. This type of breed, like in case of black Bengal goat or like in case of Garol sheep, there may be there. So we are working the molecular basis of their adaptation in high means saline zone. So that maybe that later a few of our students are already working. I think later within few years we will be developed in a that means a particular means mechanism that is also molecular mechanism that is helping this type of breed like black Bengal goat or Garol sheep for their adaptation in high salt tolerance this Sundarban area.
Okay.
Any more questions are there?
So, Dr. Kingsu will ask some questions. Or we will have questions, but okay, then I can ask one more question. That is, water in the Sundarban has high TDS content. So is this water drinkable to animal human in the Sundarban area?
Yes, sir. Yes, sir. Actually, that concept is on this concept we are working. That concept is there. Now we are very much concerned. Human are very much concerned about the TDS of water. We are telling that if TDS is very high, that will cause a problem to our kidney and different organs in our body. So high TDS, now we are using different type of the water purifier to reduce the TDS, that total dissolved solid. Okay, but in case of Sundarban, if you go to the Sundarban, not only the animals but also humans, they are taking this drinking water, and you can see that TDS is very high. But their adaptation strategy is there, which ultimately helps those people to cope up with that high TDS content. That high TDS content, and you will see that no problems of even is there. That may be a particular threshold is also there, that limit is there, maybe that limit, but they are adapted to that particular condition. If I will go to the Sundarban area or I will remain for 5 years or 10 years, then definitely I will means there will be some problem with this high TDS of this water. But there, that people, even in case of human or even in case of animal, they are not facing any problem. So that a physiological or molecular basis will be there, which ultimately helps those animals or human to cope up with this high TDS of drinking water.
Okay, thank you.
Thank you, Dr.
Also,
Patro.
I want to supplement that I have heard that in that area, iodine content is also high because
Yes. Iodine and also lead content is very high.
iodine content of that area is very high. So therefore, there are a lot of incidences and lot of incidences. Yeah. And that is the reason there are a lot
Yes, sir,
of
in case of
cancers incidences on those areas. Okay, thank you.
Sir, we have also done and we have seen that heavy metal toxicity is there, that is lead and arsenic toxicity in some parts of the Sundarban. And along with this, what you are telling, this iodine content, we have in one of our PhD students worked in Sundarban, and she find that the lead content and arsenic content is very high in the drinking water of that few parts of the island of Sundarban, and that is also affecting their people also that part of the Sundarban.
Thank you, Dr. Patro. Dr. Patro, any more questions are there? Dr. Patro.
Okay. Thank you, Dr. Banerjee.
Thank you, sir. Thank you.
Okay. So I think our today's all questions we have already placed, and Dr. Banerjee.
No, I don't have any more questions.
Nicely. Okay. Thank you, Dr. Patro, for your.
Thank you.
Sir, if there is no more questions, then we can conclude today's discussion. It's a very nice discussion. I think Dr. Kamra sir, Dr. Madan sir also are here. Sir, do you have any more questions, sir? Dr. Madan sir? Sir, do you have any questions?
No, thank you. Thank you. I enjoyed the presentation by Deepak in terms, because I know that you exposed us to Sundarban to a large extent, going around there in a boat, and we had a boat excursion into Sundarbans once when we were there. And I had another occasion with an ICR team to be visiting around, and I know that the characteristics of animals in there is slightly different than what they are in the mainland, and therefore that it's really enjoying to listen to all what Deepak had to say. Thank you.
Thank you, sir. My regards to you, sir.
Okay, Sir Sandal sir is here, sir. Any more questions, sir? Otherwise, today we can conclude the session. Sandal sir, do you have any questions, sir?
Thank you, Deepak, for good deliberation.
Thank you.
I have no question. I will discuss later and outside I have no question right now.
Okay, sir. Thank you. Rajan is also here. Okay, sir. Thank you. Rajan, do you have any more questions?
Sir, no, it's fine, sir.
Okay.
Okay.
Nice to meet you, sir.
Thank you.
Sir.
Okay.
Thank you, Dr. Banerjee, and all of our guests, Dr. Madan sir, Dr. Kamra sir, Dr. Sandal sir, Dr. Sajian, and all our participants. Today, we have concluded our second day session. Tomorrow, we have 2 sessions with every valedictory. Our session will be started at sharp at 2 p.m. After the 2 sessions, there is only 30 minutes validity program. Then after the program, 3 days once. So now, thanks to all for your nice presence and nice cooperation. Thanks to you.
Regarding, hello, Professor Das.
Please.
Professor Das, actually there is one thing is that some people are talking about the feedback form. You please tell about the feedback form last day.
That I will tell them. Today's feedback form already in the chat box. So already people are starting to return it. So after this today's return back, then we will tell regarding the last feedback form tomorrow that we will announce. Today's feedback already in the chat box. So people are already started to return it. There is no issue for today's feedback.
Okay, thank you.
Okay. So we conclude.